Okay, well, a few weeks ago I had a Diamond Planet robot on the bench for some TLC. Here's a picture of it if you're not familiar with the Diamond Planet. It's a very large wind-up robot which basically just rolls straight forward, has four wheels on the bottom, had a flint spark here, the arms raise and lower as the meter moves back and forth, and has googly eyes. Those are just black pieces of plastic which can roll around just like googly eyes. And I thought, wouldn't it be cool, since I have one on the bench in front of me, to measure it up and get everything down right in CAD where I can keep it, and maybe eventually do my own 3D printed version that's battery operated. And there have been other people that have done that. Brian Hayes on the Alpha Drone website years ago did his version of it, 3D printed. I figured, well, it'd be fun to do my version of it from the point of view as if they'd made it a battery operated toy. So in other words, put a flashing light in here and a bump and go action instead of just rolling forward slowly with a clicking sound, and instead of googly eyes, have the eyes light up or flash or something like that. So let's get rid of this picture. And here we are in a viewer where you can view an STL file. But basically I can rotate this around. And this is what I took all of the, let's pull the camera back a little, took all of the dimensions and turned them into a CAD program so that I could then work with this at a later date and make all the various parts. And I did do that, and it did take me a couple of weeks, because I wasn't working on it full time. So here's an exploded view. And I can rotate it around and we can talk about all the individual parts and pieces that are in here and everything. I wanted to go with, like I said, a bump and go drive, and I had done a bump and go project before. Where is it? Here we go. We'll go full screen. Years ago I did this YouTube video on how you could 3D print your own bump and go drive robot, and basically the head will look any direction that the thing's going to go, and there's links to the STL files in case you wanted to print and make your own and all that good kind of stuff. I'll try to remember to put a link to this project down below in case any of you want to check it out and see how that worked. But I wanted to take that basic bump and go drive and add it into this project. And let's see, let's zoom in here. So in the base I made a few changes. It's a little bit, comes out a little bit there and a little bit in the back. This is the bump and go drive unit that I 3D print and put a TT type gear motor down in there, the higher RPM one, the 48:1. And this whole part, of course, goes up in there and locks into this base part, and the wheels go onto the gear motor, and these are the idler wheels that go in the back. Here's slots for them. There's a place for the switch back here, and let's pull this down a little bit. And as you can see, there's the back detail. Got the ear detail separate. Here's your arm detail. The meter movement has lots of different parts to it. There's the see if we can pull in here. There's the separate meter part which goes through to this back panel piece, and then on the back side of the back panel there's a round gear that goes there, and then this is a straight linear gear. We can look at it from this side. Here, let's go a little bit further. Here we go. So it's a rack and pinion type drive, and that all fits into a slot in here, which is going to tie into the arm linkage via this slot here. So when the arms raise and lower, the meter in the front can do a full swing left and right. Let's pull back a little, and let's see here. So up in the head there's separate insert pieces which I would print in a translucent red, which then would push into there, and they have 5mm holes in the back. so that I could mount LEDs into them so that they'll glow. Down below in the spark window, let's see, let's raise this up a little. Here's the spark window and here's its insert, as you can see from the front. Then the insert could push into place. Right, there's the insert. Let's close in on that a little. And what I'm going to do there is on the bump and go drive, I put in this eyelet on this side and there's one on the other side, so I can put two flashing LEDs which would then shine into that part. And let's see, I guess what I'm not showing here, and I have added, is this cam, and it's going to be an N20 type motor of 15 RPM at 3 volts. It goes around and around. That's going to drive the arm linkage to make the arms go up and down, and the arms going up and down make the needle move. But off of the same housing, let's look at it from the other side. But off of that same housing, I designed a part that's vertical, and it'll have a piece of spring steel on it. So every time the peg, there's a hole, if we can close in on it. Yeah, it's kind of hard for me to close in on, but basically there's a hole there on this disc where there's going to be a screw. When it comes through, that screw can then hit a piece of spring steel and pull it away, and then it'll slap back. So that'll be the clicking sound as the thing runs. I wanted to keep the clicking because that was one of the functions of the original toy. And I can also, since that's spring steel, I can use that to conduct to make the eyes flash on and off with the clicking sound. So every time it's getting ready to click, the eyes will go out, and after it clicks, the eyes will stay on. And because LEDs draw such a small amount of power and the TT motor draws such a small amount of power, there's no reason to run it on huge D-cell batteries back in here or anything. So down in the bottom part, let me see if I can rotate this in a different way. Yeah, I'm gonna attempt to try something here. Let's see if we can do this. Click on here, click on rotate. Let's rotate this whole mass to its side. There we go. And now let's see if we close in. Now if I show you the bottom, you can see it clear. So there's a place for the on-off switch to go. Here you can see the idler wheels go in. They have axles that pin them in place. But there's an insert area right there where I'm going to put two AA batteries, which will be more than enough power to run the TT motor. And the small N20 motor is only going to draw like 17 milliamps. And the LEDs, I have fairly large current limiting resistors on them for a 3-volt system, so they'll only be drawing probably somewhere between 17 and 20 milliamps also, so very, very little. I don't know if we can see anything any different when we're on our side here. But we can take a look from the top. But there we have it. For what it's worth, let's go back to the altogether ones. Basically what it should look like when it's all together. The only real difference on the outside from the original toy and this one is, you can see it added kind of a bulged area there to have enough room for the on-off switch and the battery box. And then on the front there's a little bit of a bulge. Here, let's close in this way, let's move this up. A little bit of a bulged area there for the bump and go drive. Other than that, I tried to keep everything about the same size. Let's bring this back down. Let's pull back. So, next up is to start printing these. Some of these parts being so big, and like the body halves, they're going to have to print with supports. I'm not going to need supports on the arms, the ears, the base. In fact, the only thing I can think of I'm going to need supports on is going to be on the body, front and back. And it'll be a lot of supports because it's such a big piece. So this probably will be 24-hour print times on both front and back on a standard Prusa printer. Of course, if I had one of the new Bamboo Labs or the Creality's new version of the Bamboo Labs, they print 3 to 5 times faster than the old Prusa with higher print quality. But I don't have the money to spend on another printer at this point. So we'll just kind of have to put up with the 24-hour print time on this instead of being able to do it in 12 or 15 hours. I got time. And I really want to try to do a paint job that would match the original, but the original has a hammer tone, you know, hammer finish. It's kind of a blue-green color, and they actually used to sell a spray hammer tone paint in that color, but they quit making it back in 2009. So now if you want to buy a can of it, you have to buy it from people that had hoarded it. And there's some people online, they're selling a single can of that stuff for as much as $280, or at least that's what they're asking. I can't imagine they're actually going to get it. You can still get some hammer tone colors. You can still get silver, silver gray. Then they got lots of the ones like bronze and gold and stuff like that. But as far as getting the right color, I might be out of luck on that. I haven't quite decided whether I wanted to pay the price. So I might just give it kind of a blue paint job. We'll see. We'll see in the next video what I end up doing with it. But here's the basics of what I'm shooting for. So if you're interested in seeing a 3D printed diamond planet with bump and go action and flashing lights, then stay tuned for part 2.